Welcome to part 2 of our interactive notes here. Let's put on our heading name, number, date, first and last in cursive. Remember to write the date that you are doing the notes, not necessarily the date I'm writing here. May be the same, may not. And our subject is math. Alright, so the first two questions have to do with making sure we know when we can compare fractions. So can these two shapes, even though they're both showing two pieces shaded in out of 3, so this is 2/3 and this is 2/3, can these two fractions be compared? Can I say that this 2/3 is equal to this 2/3? No, I can't. No. These two fractions can't be compared because, remember it says to explain, and here's the explain part. Because the shape of the whole, that means the whole thing, is not the same type of shape. We have one circle, we have one rectangle. They're not the same type of shape, so we can't compare them. They have to be the same type of shape. How about these two? I have 1/4 and 1/4. Can we compare these? They're both rectangles. But this goes back to that king size candy bar and that little itty mini candy bar. If you got this piece and your brother got this piece, you would not be happy because they are not the same size whole to begin with, so the pieces are not going to be able to be compared. They're not the same size. No, these two fractions can't be compared because the whole shapes are not the same size. They're the same shape, but they're not the same size. So the whole shapes are not the same size. So they have to be the same size, same shape. So here we have two where the whole rectangle, they're both rectangles, they're the same shape and they're the same size. So we want to compare 3/5 compared to 2/3. Now be careful, in future ones we will have subtraction. Notice how the line is down low and not right in the middle. This one has to do with compare. It also says compare. Sometimes I may want to subtract them. The line will be higher. So we're going to compare 3/5 and 2/3. Well, this one's cut into 1, 2, 3, 4, 5 equal pieces. Remember, your shape has to be cut into equal pieces for that fraction also. And we need to shade in 3 of them. And this one, we're looking at 2/3. So there's 3 pieces, and we need to shade in 2 of them. They're pretty close in the amount shaded in, but it looks like this goes a little bit lower, so the 2/3 is a larger area shaded in than this one. Sometimes it can be hard when the shaded area is close, so look at the unshaded area. This has a lot less to fill in for the whole thing to be complete than this one. So that means this is greater. So 3/5 is less than 2/3. Here we have the same shape, both circles. They're the same size, so we can use these to compare. First one has 7 pieces. I need to shade in 5 of them. And this one has 5 pieces. I need to shade in 4. So it may be hard to tell which one has the greater area, but if I look, this piece left over is smaller than these 2 pieces left over. So there's less that I need to complete this circle to fill it all in than this. So that means this is a greater amount. So 5/7 is less than 4/5. Okay, here we have on our fraction bar, we have 1, 2, 3, 6 we need to shade in. And we need to shade in 5/10. So 1, 2, 3, 4, 5. Exactly the same amount is shaded in. They're both exact same area. So 3/6 is equal to 5/10. They are equivalent fractions. They're actually both half. 3 is half of 6, 5 is half of 10. So they're both exactly half of the whole. They are equivalent. Okay, last one, we're going to use a number line. So these are different things we can use as models to compare fractions. So a number line, there's 7 pieces. I need to shade in all the way up to 6. Here we have 9 pieces. I need to shade all the way up to 6. Well, this line from 0 to 6/7 is much longer than from 0 to 6/9. So it's a larger area. So that means 6/7 is greater than 6/9. Alright, so now I'd like you to do some more practice with comparing fractions using models. Thank you for joining me.